There we go. Okay, so all this transformation does, since f of x is your y coordinate, it just takes your y coordinate and changes it to 1 over y. That's the only thing that's going to happen. I could say lesson done, because that's it. The y coordinate changes to 1 over y. Just like when you did these ones, the y coordinate, you had a point x comma y on your original graph, and all you did was change your y coordinate to the square root of y. Same idea as that in chapter 2. And you could say we were done there, but there's a lot of interesting things that happen. We noticed with the square root that where the y value was 0 and 1 didn't change. Certain parts were above and certain parts were below the original graph, and we sort of characterized it. Well, we're going to do the same thing here and characterize what happens. Now on that colorful sheet that you have, what I've done is I've given some steps for graphing reciprocal graphs when they look like this, 1 over f of x. The bold is actual steps. The stuff that's not written in bold is a little explanation of why you would do that. So what we're going to do is we're going to draw the bottom graph first, whatever it is. We're going to do asymptotes wherever you have x-intercepts on your original graph, because that's where you would have asymptotes on the bottom non-permissible values. We'll go through these kind of quick, because then we'll go to an actual example and then refer back to this. Okay? We learned in chapter 2 that you have a horizontal asymptote when you look at the highest power. This time you can say the same thing by looking at your original graph. If your original graph goes up forever or down forever, then you're going to have an asymptote at y equals 0. And all of these ones, because they're a 1 over graph, if they have a horizontal asymptote, they're going to have it at y equals 0. We're going to plot a bunch of points. Sometimes we're going to plot where the y coordinate is equal to 1. Other times we're just going to plot nice points. So we're going to plot a bunch of points, and all we're going to do is take that y value and do 1 over y. We're going to look especially at maximum and minimum points to figure out where they're going to go. Because if you have a maximum, say the value is 10, that's your biggest value. When you do 1 over 10 on your other graph, it will become your smallest value. Because the bigger number you have on the bottom will become a minimum. And then at the end, since you'll have a bunch of asymptotes, you're going to connect your dots and draw it towards the asymptotes and see what it looks like. So now what we have is a bunch of examples that I've given to you. I have them written out step by step of what to do. But we're also going to graph these as if we were starting it from scratch. So what I've done here is I've done each individual graph separately so that you can see the steps later on. But I'm going to also show you how we would do this, because you wouldn't draw out all of these steps if you were doing the question. You would actually graph 2 different graphs. So I'm going to show you what that would look like. Okay? So according to the steps, you graph the bottom first. 1 over x squared minus 4 is, the bottom is x squared minus 4. That's a parabola that's been moved down 4. If you factor this, you can see that minus 2 and 2 are the x-intercepts, because this is the same as 1 over x plus 2, 1 over x minus 2. So the same as in chapter 2, those are non-permissible values that don't cancel out. You would draw asymptotes for them. What this method says is if you're doing a reciprocal graph, wherever you have x-intercepts on the original graph, that's going to be where y is 0, and those will be non-permissible values when you do 1 over that. So same idea. Now, according to this technique, since the graph goes up forever, we'll have a horizontal asymptote at y equals 0. Using your technique from chapter 2, the highest power is an x squared, and you have no x squareds on top, you would have a horizontal asymptote at y equals 0. Then for plotting points, what are points that you know on your graph? You know 0, negative 4. For x squared minus 4, can you see that if you plugged in 1, you would get 1, negative 3? And if you plugged in 3, you get 3, 5. So when you go to graph these, what you'll do is you'll draw your original graph here. On a second graph, right beside it, you'll start by going and saying, I have x-intercepts at minus 2 and 2. And because my graph goes up forever, I have a horizontal asymptote at y equals 0. Then I'm just going to take some points. What happens at 0, negative 4? That's going to become 0, 1 over negative 4. Because all that happens is the y values change to 1 over y. What's going to happen to 1, negative 3? It's going to be 1, 1 over negative 3. What's going to happen to 3, 5? 3, 1 over 5. Can you see over here that you would also have negative 3, 5? So over here you would have negative 3, 1 over 5. So you take some of the points that you know. It's important to do the minimum one because that is going to be as high as that graph gets in that section. And now you've got asymptotes, you've got some points. These graphs will never cut through. You know how we had some ones that cut through an asymptote? If you have a 1 over f of x graph, it will never cut through the asymptote at y equals 0. And you just have to draw it in its sections to finish your graph. So for graphing, y equals x squared plus 1. All the steps are there. You would draw this graph first because that's a parabola moved up 1. Then you would go to your reciprocal graph. Do we have any x-intercepts? No. So there are no vertical asymptotes. In fact, can you see that there are no non-permissible values here? The bottom will never equal 0. Does the original graph go up forever or down forever? Yes. So we will have an asymptote at y equals 0. Let's look at some points. We've got 0, 1. Can you see that when you plug in 1, you'd have 1, 2. When you'd plug in 2, you'd have 2, 5. Similarly, over here, you'd have negative 2, 5. And negative 1, 2. What's going to happen to those points? Well, negative 2, 5 will be, change color, negative 2, 1 over 5. 1, 2, negative 1, 2 will be negative 1, 1 over 2. What's going to happen to 0, 1? It's going to stay the same. Because 1 over 1 is still 1. And because of symmetry, this one's going to go there and this one's going to go there. And you did these in grade 11. Did you come up with special names? Do you remember the special name for this one? Speed bump. Does that ring a bell? So come up with, it's not an actual mathematical name. It's not like if you look up speed bump in Wolfram Alpha, you'll find all of these graphs. But yeah, we called this one speed bump. Do you remember? Do you have a name for that one? Sad clown face. Okay, kind of looks like, oh. Okay. So here we've got a square root graph on the bottom, while the square root of x plus 4 would just be moving x plus 4 to the left. What you would do is you would graph that one first, then off to the side. You would ask yourself, do I have any x-intercepts? Yes. I have an x-intercept at -4. There we go. X equals -4 is our asymptote. We look at the points that we have. What's going to happen to -3, 1? Oh, first of all, this square root graph does keep getting bigger and bigger. And since it does go up forever, there will also be an asymptote at y equals 0. So -3, 1 stays the same. What's going to happen to 0, 2? 0, 1 over 2. And our final graph will look like that. So a bunch of the times you'll get a question where what's on the bottom of the graph is something that you could graph from your transformations unit. It could be anything on the bottom. Usually they're pretty nice in that they don't put, you know, I don't think they'll ever put something like this on the exam, but they could, right? You'd have to take your log graph, move it 2 to the left and 3 down, look at that final log graph, and then do these steps to that graph. Wouldn't be hard, but I don't think they're going to ask you a log graph on the bottom. Typically, it's one of the more straightforward ones. We will, in tomorrow's class, look at sine, cos, and tangent, because they have put those on a fair bit. So we're going to look at those ones tomorrow. Sometimes, though, if they want to just see if you know how to work with reciprocal graphs, they just give you a crazy-looking graph to begin with, like this one, and say, can you graph 1 over f of x? So you already have step 1 done for you. You just have to go through the process and say, wherever I have x-intercepts, I'm going to have asymptotes. So you see I have an x-intercept at -1. Looks like I have one at 2. And 3, 4, 5. Wow. An extreme asymptote equation. Does this have an arrow that says the graph either goes up forever or down forever? Yes, it does. So we will have an asymptote at y equals 0. So always start by drawing our asymptotes. Then we just go to our points. We'll need points in each section. What's going to happen to -5, -1? It's going to stay the same. -2, -1? Going to stay the same. In fact, this whole line will stay straight, just like it did before. I'm going to add a point in here. I'm going to add right here. It looks like that's at -1.5, 0.5. And I'm going to write the 0.5 as a half. Because what the reciprocal graph does is the same thing as reciprocal means. It just means flip a fraction. What's going to happen to that 1/2? It's going to be negative 1.5 comma 2 over 1, because that's what a reciprocal does. Now you might have said, I know how this graph is going to go because there's an asymptote above it. It has to go down, but sometimes it's nice to have a point that shows you which way to go as well. 0, 1 is going to stay at 0, 1 because of the asymptotes, and it can't cross asymptotes. This is going to go up. But maybe you could also see here is another place where I have a half, so it would become 2. Here is another place that's a half, so when you do the reciprocal, it would become 2. And that helps you see that it has to go up in that section. 4, negative 1, that won't change. This section will have to go down. And again, you have some points where there's a half, so you could see that that negative half would become negative 2. Oh, I forgot the negative sign on this one and this one before. Sorry about that. And finally, we've got 6, comma 1. That won't change, but this part of the graph will look like that. So I've got a handout for you to do some practice on these. And like I said, tomorrow we'll do all of sine, cos, and tan when you do reciprocals. And then we'll be officially done.